Okie dokie. I'm going to make part of a video. I can't imagine I'm going to do the whole thing, but I'll get started. So pay attention to what this is saying. The words really matter. It says write an equation for a parabola equation as an equal sign that opens down as in negative a, meaning a negative out in front, and x-intercepts, meaning zeros of that. So back to what I always do, factors and zeros, think about what factor goes with each of these. So first of all, f of x is going to equal, and I'm going to toss a negative out in front so that it will open down. The factor that will go with a 0 of negative 4 is x plus 4. And the factor that will go with 4/3 is going to be 3x minus 4. And you kind of just need to wrap your brain around that. I'm going to leave that negative hanging, and I'm going to FOIL that. So I'm going to get 3x squared. Outside is negative 4x. Inside is positive 12x, and then minus 16. But I'm going to be distributing that negative. So my final function equation with an equal sign, distributing this negative, could these combine to be an 8x together? And then distributing the negative, I get negative 3x squared minus 8x plus 16. Just because this negative makes that negative, makes the 8 negative, but changes the 16 to positive. So that meets all the criteria. Factor, okay, completely means that you might get some I's in your answer. We now are able to factor beyond the real number system. Okay, in this first one, if you looked at the key, it was done a little differently. I still like to do this way if I have a number out in front. It did take some thinking though, because I have to multiply 4 times 21 and get 84. And then I had to figure out ways that were going to be factors for 84 and subtract to be 25. So after much noodling, I thought of 28 and 3. And to get a negative 25, I would need a plus minus combination like this. And then you always have to reduce one or both in that scenario. So my first factor stays 4x plus 3, but here you can divide out a 4, so my second factor becomes x minus 7. I just realized my phone is probably on, so I'll turn it off because, you know, I have so many friends and they just are constantly messaging me and, okay, not really. But my daughter's on the road, so she could potentially call. Okie doke. So that is that. And keep in mind, it is not a mystery how many factors you should get because this says 2. So I should have 2. This says 4. So I should have 4. This says 4. So I should have 4 because the fundamental theorem of calculus says the number of zeros and the number of factors should equal your degree, which is the highest power. So anytime your leading power is double the middle power, you can factor it kind of by unfoiling, basically. So I'm going to have to start with an x squared here and here, and I'm going to need to find a way to make 144 that subtracts to be 7. And so I'm going to end up with a 16 times 9. Keeping in mind that it's pretty common, since this is a square here, you're going to be breaking it down into squares. So in order to get a 9 that's, a 7 that's negative, I'll need a negative 16 and a positive 9. By now you should be pretty savvy with this difference of squares here, but keep in mind that the other one, you now can kind of break apart because like what you really did here was think x squared minus 16 equals 0. So if I add the 16 to the other side and then I square root it, I'm going to get my plus or minus 4. If I did that with this side, I'd be looking at x squared plus 9 equals 0. So x squared equals negative 9. So ultimately what happens is this will break into plus or minus 3i. And so that's what happens is I get my 2 real and 2 imaginary. These are going to be, like if I was doing my zeros, this would be negative 4, positive 4, 3i, and negative 3i, which makes sense because I always have to have zeros that come in conjugate pairs. Now this one's not asking for zeros, it's asking for the factors, but you always have one factor per 0. They always match up. So here I'm looking for 4 again because the power is 4. This is the difference of two squares. This is the square of x squared. This is the square of 4. So we're going to end up in a very similar situation, which means you're probably going to end up in that situation on the test as well, where this is in our real number system and we're used to working with it. And so I have my x plus 2, x minus 2. And then now that I've kind of learned that the sum of two squares breaks down similarly, except that it's going to be a plus 2i and a minus 2i. Because if I FOIL these two out, I'll end up back where I was. And that's the only way to get that plus in the middle, is to have some imaginary values. So again, not surprised to see my factors with conjugate pairs in there, because that will generate zeros that are conjugate pairs. But this is asking for factors. Okay, so first of all, this one is all spread out. This is in standard form. I'm looking for the highest power. It's in standard form, highest power first. And I don't have to add up all the powers because I don't have factor form. So factor form looks like this down in number 5. And that is where you have to figure out, okay, I have a negative x, third power plus fourth power plus second power plus third power. That's where you have to look at all of this and like think, what would happen if I did multiply that all out? I'd get negative x to the 3, 7, 9, 12th power. And then this is the term you use to determine end behavior. But if you have just a standard form polynomial like this, where your terms are all already multiplied out and separated, you literally just look at the first term and ignore everything else. So since it's a -2 coefficient in the lead, the right is going to go down and the left is going to do the opposite because my power or degree is odd. Make sure that it's in standard form, meaning highest to lowest power. So this one goes 5, 4, 3. So I'm looking for the highest power when it comes to graphing and thinking about end behavior. Okay, so I have to factor this out. And so looking at my options, I'm going to pull out a GCF. So I'm going to take my function, and it says factored form. So that's just a different form of the polynomial. So I'm going to leave it as a polynomial and start with f of x equals. Okay, then I'm going to pull out my greatest common factor, which looks to be -2x cubed. That will leave me with an x squared, a negative, because I'm pulling out the negative, which is always what you want to do. I made you like swear to do that last time. So I'm pulling out the negative with my GCF. That'll turn this into a positive 4x, and that'll turn this into a -12. So then that part factors further. So I have my -2x cubed, and then here I'm looking for 12 in a way that subtracts to be 4. So I'm going to use 6 and 2, give myself more room. And then I need it to be a positive 4 according to this. So I'm going to put a +6 minus 2. So that's my function in factor form. So since I'm writing the function, I write it with my f of x. Now I'm doing zeros. Well, every factor determines a 0. And some of you just ignored this part on the last test or quiz. So make sure that you will look into that. Multiplicity means repetition. And repetition is determined by exponent because exponents are multiplying repeatedly. So this -2x cubed factor provides me with one of my zeros at 0. But because it's to the third power, it has a multiplicity of 3. My second 0 is at -6 because of this. And my third 0 is at 2. Neither one of them is raised to a power, so neither one of them has a multiplicity. And so when I go to graph, I have to know the meaning of that. Keep in mind that an even multiplicity is a bounce, but 3 is odd. So technically it'll snake across, but I'm not going to be really particular about that. You can just have your graph cross it. This has no multiplicity, so it'll cross x. This will cross x. You only get a bounce like this and this if that 0 has a multiplicity that's even, and ours don't. So at -6, so 1, 2, 3, 4, super happy about that, 5, 6, and then at +2, and then at 0. But don't forget what you know up here. Your right is going down and left is going up. So right end down, left end up, and it's crossing, crossing, crossing. And then how far down this goes, how far up this goes, not going to be picky about that. Okay, this is definitely going to happen. You leave it in factor form, but it says give an equation. Equations have equal signs, so do that. Now, be conscious of what you know, my friends. This is the right end, and it is going downward. You need a negative out front. The left end is going up. So that tells me that in the end, I best have an odd degree because that's the only way that happens. So let's see. This 0 occurs at -2. It has even multiplicity because it bounces there. This 0 occurs at 0. It also bounces, so it also has even multiplicity. I don't honestly know if it's 2, 4, 6, 8, or 100. I just know it's even. So there's multiple correct answers. And then this one just crosses through. So I'm going to say that does not have multiplicity at my 0 of 3. So go through and do your factors. I like to have the 0 out in front. So I'm going to put x to an even power, and I'm choosing 2 to make my life easy. Then I'm going to have the factor that goes with a 0 of -2. And so x plus 2, that also bounces, that also needs an even multiplicity, and so I'm also picking 2 for that one. Could be a 4, could be a 6. And then lastly is this 3, so the 0 that would go with that is an x minus 3, and since it crosses through, it doesn't have multiplicity, and I'm done. So did I do what the words say? Did I give an equation? Yeah, there's my equals sign. For f of x, yeah. Did I leave it as factors? Yes. Will my right end go down? Yes, because of my negative out front. Will the left end go up? Well, let's look. I have a power of 2 here, plus 2 in the middle, and then this one has an invisible 1. So basically, if I multiplied this out, I would be at -x to the 5th, which does indeed have an odd degree. So yes, the left end would do the opposite, and all would be good. So take your time. The instructions on the test are going to say, use your big brain, pay attention to detail. You know, the words matter, so be careful about that. I think a lot of people hurry through it and leave some points on the table that they would get if they thought it through a little bit more. So I already did some of the footwork here. I determined the degree of the leading coefficient. I see that it's negative in the front, so my right end's going to go down. My power is 12, which is even, so the left end's going to do the same. We've been doing that a while, so I think most of you are pretty good at that. Here I have a 0 at 0 with a multiplicity of 3. So that's going to technically snake across, but you can just draw it going straight across. I have a 0 at -2 with a multiplicity of 4, so that's going to be a bounce because it's even powered. Here I have a 0 at +2 with a multiplicity of 2, which is also even, and so that's going to be a bounce as well. This will generate a 0 at 4/3. It has odd multiplicity, so it will simply, well, technically it would snake across, but it'll just can cut across. I don't really care. So 4/3 is like 1 1/3. So we'll go there. So my right end has to go down. So from the rightish 0, I'm going to head downward. Then my left end is supposed to also go down. Okay. So there you go. So now it's just like sketching the rest. It needs to bounce back down, needs to snake across, which is just crossing in my book, cross back down, and then bounce. So I don't care, like, how low does this go? Don't care. How high does this go? Don't care. How low does this come down? Don't care. What I care about is those pieces you know. This end down, that end down, 0, 0, 0, 0, bouncing at the -2 and the +2. So those would be the things I'd be looking for. Okay, intermediate value theorem is an eyeball activity. It is not a calculation-based thing at all, as long as the table is given to you. Water break. So the table's given to you. You don't have a calculator, so you can't generate one on your own. And it says, determine between what pairs of consecutive integers f of x will contain. And so you're looking at these, but the x's are going to be the actual answers and locate what's happening. A 0, my friends, means that y changes from positive to negative or negative to positive, because in order to do so, you have to cross through 0. So as I look, it goes from 12 down to negative 4. It must pass 0. Then here it goes from negative 3 to positive 6. It must pass 0. Then there's a change in sign between these two y's, so it must pass 0 again. So there are 3 zeros, and they occur between negative 4 and negative 3. This one occurs between negative 1 and 0. This one occurs between 2 and 3. X's are your location. So when you're trying to locate something or say where it's happening, you're looking at your X's. In part B, it's asking where will y have a value, like between what two numbers will y have a value of negative 6? Intermediate value, between. Intermediate means in between. So I'm looking for when it would pass negative 6. Well, none of these, between 12 and negative 4, doesn't go down far enough to hit negative 6. It actually won't do that until here. The only time your value, your graph, will dip down far enough for y, or f of x, to take on the value negative 6 is on its journey from negative 4 down to negative 10. And so that occurs here, between 3 and 4. This one is asking, because words matter, it says, what is the minimum number of times? It's not asking where. It's just saying, where will the function take on the value of 2? Meaning, where will y be 2? When will f of x be 2? How many places? So, same question as the previous. You're just looking for it to bypass 2. Okay, well, on the way from 12 to negative 4, it's going to have to pass by 2. On the way from negative 3 up to positive 6, it's going to have to bypass 2. On the way from positive 3 down to negative 4, it's going to have to go past 2 because 2 is between. So there are 3 places that it has to do that. And it says minimum number. That's just because it could be more, but this is all we know based on the part of the chart that they're showing us. The chart goes to infinity. We don't have that kind of time. All right, let's take a couple more. Find the max value. Okay, max value. I'm back to doing my chart, my quadratics, because I can see right here, this is a parabola. It opens down because that's negative, so the vertex is going to be the max value. Max value is asking how high is the high, so it's asking for the y coordinate of the vertex, but when it says at what value of x does it occur, it's asking for the v sub x. So let's find both. V sub x, since this is in standard form, will be the opposite of b over 2 times a. And then take your time. This is where a lot of people made mistakes in simplifying. And so negative 12 over negative 6 is going to come out to be a positive 2. So that's where it occurs. So at what value of x does it occur? It occurs at x equals 2. What is the value of it? Well, that's going to be the actual y value. So I'm going to go ahead and put, oopsies, got my 3 there, put in the 2 for all of the x's up in the original function. So be careful. Some of you are still making mistakes with this. PEMDAS is real. So you have to do the power first, 2 squared is 4, and then multiply it by the negative 3. Then in the middle you have a 24 and then a 1. So when you do that all out, you get 13. So you have a max of 13, that's the value of it, at 2. Because this point is located at 213. So you're saying I have a maximum value of 13. It's located at x equals 2. Okay, what transformation, meaning what change takes place between these? Well, the container is the same, x squared. So it's asking you to identify all the things that happen when you have a negative out in front, and then a 4th as an a value, and then a +2 here, and a -3 out here. So you have to kind of describe each thing. The negative is going to reflect it or flip it over the x-axis. You can't just say flip it because I won't know over x or y. So it flips it over the x-axis. It's going to have 1/4. It's going to be wider, you could say, or you could say that it's going to be a vertical stretch. Actually, that would be a horizontal stretch. So if you're calling it vertical, you'd have to say like a vertical shrink. it's going to be kind of like, instead of going up, like to the first point, instead of going down 1, over 1, down 1, back 1 to create it, it's going to go down 1, over 1, 2, 3, 4 in each direction. And so it's going to be wider in that manner. But you're just trying to get across the point. And there's a chance that that'll be matching or multiple choice, so you won't have to come up with the word. What does the 2 do? In here, it's going to move it 2 to the left because it's inside the container. And here, it's going to go down 3. If it asked you for the vertex on this one, you would give the vertex as -2, -3 because it's vertex form. And you can get the vertex simply by looking at the opposite of this number and then this number as is. So that's still off of the chart. Oops, that's down 3. Okay, so now we're getting into complex numbers. So this is actually after the quiz, like all the stuff from the quiz that we already took for up to what is it, 2-3, kind of ends here, it looks like. And then this is where 2-4, 2-5 started. Okay, so I think of this as 5i, and this is 3i, because they both have a negative, but they're both perfect squares. The real parts multiply to be 15, and the i's multiply to be I squared. But I squared has a value of -1. Do not let yourself forget that or leave that in your answer. So this is really 15 times -1, so my answer is -15. If it's in standard form, technically you would have plus 0i. Here I have to FOIL, and like I said in class, treat I like x until it's squared. So first is going to be 12. Outside is going to be 28i, inside's -6i, and last is -14i squared. But I squared is a -1, so this whole thing on the end is a value of 14, which can now combine with the 12 to become the real part of 26. And then the two imaginary parts can combine to become a positive 22i. Okay, I to the 65 is kind of confusing, but that's the one where you have to figure out the remainder. You take the power, you divide it by 4. 65 divided by 4 is going to lead to a remainder of 1 because 4 goes into 64, but not 65. And so then you think back and go, okay, remainder of 1 means I'm going to be in the first of my 4 options. So my remainder of 1 is an I. And so then my answer is going to be I. Keep in mind, like, the remainder of 2 would be an I squared, but I squared is -1. A remainder of 3 would be I to the 3rd power, which is the previous one, which is R squared, times another I, so you'd have -I. And then when there's not a remainder, when it went in evenly, that's when it came out to be a +1. So these are the 4 parts of the cycle, and then you need to divide whatever your power is by the 4 and pay attention to the remainder, not the answer, not how many times it goes in. Don't care about that. Only care that I have a remainder of 1. And that'll tell me where I'm landing on my 4-part repeating cycle. Okay, so let the fun begin here on rationalizing. To rationalize, you need to use, I'm sick of my red, so we're switching. You need to use the complex conjugate, in which you only change the middle, so the sign of the I switches. So I'm going to FOIL on the top and I'm going to FOIL on the bottom. The top might stay messy, but the bottom has to clean up. The I has to go away. That's the entire purpose. So if I FOIL the bottom, I get first, outside, inside, last, -36i squared. These always cancel or you did something wrong. And then this is going to become a +36, and it's going to add together with that 16 on the bottom. And so the bottom is going to actually become a 52. Foiling the top, I get 2 times 4 is my first. And then here for my outside, I get -12i. For the inside, I get another -12i. Penny says hi. And then these negatives cancel. 18i squared. Hang on, I have to yell at her. Penny, come here. Free dog. You have to be quiet because I'm making a math video. Okie dokie. Thanks, honey. You're the best. Lying. Okay, so negative 18 and then 8 is going to give me a negative 10 for the real part. And these do not cancel because they're both negative. So I know you want them to cancel, so do I, but they don't. And so there's that. And then you can separate and reduce that. So if I have negative 10 over 52, because we're supposed to be writing it in standard form, and then I have negative 24 over 52i, negative 10 over 52 will reduce to negative 5 over 26, and negative 24 over 52 is going to reduce to 6 over 13. And so that is my final answer in standard form, which is what it says up here underneath all my scribbly scratches, is that you want to be answering in standard form. Oops, just crossed it off. So A plus or minus your BI. Okay. Okay, so E is not a rationalizing problem, but it is still tough to noodle your way through. Think of this as a negative 4 and a 3 and then a plus 3 at the end. This is going to come out as a 2i, which is separate from the negative out in front, and this is stuck under. And there's nothing that I can do. I can't really add them because this 3 doesn't have a square root. So the 3 is the real part, and then the minus 2i root 3 becomes the imaginary part. And so in standard form, I have to flip-flop those. This is rationalizing, but it requires you to use the conjugate, which would be the opposite I value. So I end up on the top with 12i, and I end up on the bottom with negative 9i squared. So that's going to turn into 12i over positive 9, because this has a value of negative 1 times the negative 9. But then 12 over 9 reduces, and I'm back to 4/3, but I end up with I on the outside. So it's rationalized because the I is not in the denominator. Okay, so really excited about using long division for this. So you might be like, yeah, but I could just write this as x plus 3/2. You could, but you still have to do long division because it says so. So you're demonstrating your understanding of that concept. Watch for 0, place savers. I have 2x cubed minus x squared plus 4x plus 22. Okay, so I don't have any spaces to save. And then I have a 2x plus 3, so I don't have any missing powers of x. So I ask myself, what do I have to multiply 2x by to get it to be 2x cubed? And the answer is x squared. So I toss down an x squared, and I like to keep it lined up above the other x squared. And then I'm going to multiply this top x squared by this whole thing. So I'm going to have to do a little distributing. So x squared times 2x and x squared times 3. Then I come motoring through here, and I go ahead and I subtract the bottom row. So that's going to be subtraction. That's canceled as it always should. And then here, these two, a negative 1x squared minus 3 more is negative 4x squared. And this is where some of you got lost, was just in the adding and subtracting. So take your time. I bring down the next victim, and then I start over. I say, how do I make 2x equal negative 4x squared? Random blob. And the answer would be to multiply it by a negative 2x. And so I repeat. I just go back and do the same exact thing. I take this negative 2x times this entire side part. So negative 2x times 2x and negative 2x times 3. Oops, minus 6x. Coming through here to subtract, which really just changes the sign of the bottom row. Always get that canceling or you did something wrong. This turns into 10x, and I bring down the next victim. And I start over. What do I do to 2x to make it into 10x? I need to multiply it by a 5. What do I do with anything on the top? I multiply it by what's going on over here on the side. So 5 times 2x and 5 times 3. So when I come along to subtract the bottom row, this cancels as it has to, but this next part doesn't. I get 22 minus 15, which is 7. That is left over, and that is my remainder. So it is not going to say QR on the test. It is going to say to write your answer in proper form. So I talked about this in class a couple of times, and the proper form is going to be my answer from the top So x squared minus 2x plus 5. Then I'm going to add my remainder over what I divided by. So this is how my answer looks. It's like a mixed number. Divide using synthetic division, and it's going to say the same exact thing. It's going to ask you to write your answer in proper form. So here I have a negative 3x to the 4. I have 2x cubes. I have 0x squareds. I have 0 plain x's, and then I have an 8. So I am putting a 0 in for everything that I am missing for a power of x. So you don't write them in here, but you're thinking, okay, this was an x to the 4, x to the 3rd, x to the 2nd, plain x, constant. And since I didn't have x squareds or x's, I have to save a spot with zeros. All right, and then I am divided by x plus 3. That's the potential factor, and so I use the opposite of the potential 0 in there. I drop this negative 3. I multiply anything on the bottom times what's in the box. Then I add 2 plus 9. A lot of mistakes on this part too in terms of just adding. Negative 3 times 11 is negative 33. 0 and then plus negative 33 is going to be a negative 33. Here I'm going to get 99. These are kind of gross numbers, but they're not completely impossible. This is going to turn into a negative 297. And when I add 8 minus 297, I get negative 289. This, my friends, is the remainder. So if the question were to ask me, what is, is x plus 3 a factor? The answer is no. This is not a factor. It did not go in evenly. Also, if it asked me, I'll leave it at that. If that was a 0, the answer would be no. So writing my answer in proper form, again, means I need to write the answer part, which is this guy. Keeping in mind that this started as x to the 4th, I've done one round, so it'll drop to x to the 3rd. So writing my answer in proper form, I'm going to get negative 3 x to the 3rd plus 11 x to the 2nd minus 33x plus 99, and then plus a negative 289, which is my remainder, over what I divided by. And that is your proper form for your quotient remainder. Okay, let's see. I guess I'll just tackle my way through this. Given that x plus 3 is one of the factors, aka negative 3 is a 0. That is a real 0. Therefore, it does not come in pairs necessarily. Keep in mind that you should have 3 zeros. You were given 1. So when it says all means all. So there's 1, 2, 3. I'm already going to write down one of my answers. Let me double check. Find all zeros. Okay, so I'm writing the zeros, not the factors. If it says to write zeros, write zeros. If it says to write factors, write factors. So, all right, where am I at? I am going to go ahead and take my 0, knowing that it's supposed to go in. Oops. And so I'm going to have my 1x to the 3rd, negative 1x squared, positive 1x, and then a 39. And I am fully expecting a 0 here or something's wrong. So I drop my 1, I get a 1, times negative 3. I get negative 4 because I'm just adding them together, combining them. That's going to be 12. That's going to be 13. That, thankfully, is going to be negative 39, and that is going to be a 0. So I end up with x squared minus 4x plus 13 equals 0. The only factors for 13 are 13 times 1, which do not add up to 4. So I'm just going to have a little sad face moment because I know I need to use the quadratic formula. So I'm going to go ahead and do that. I'm going to have an a value of 1, a b value of negative 4, a c value of 13. So I'm going to have 4 plus or minus the square root. Now be careful. If you square a negative 4, you're going to end up with a positive 16. That number always, 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 always has to be positive. Minus 4, which is part of the formula, times my a and my c all over 2 times a. So this underneath here is going to turn into a negative 36. So I end up with 4 plus, I don't know where to write this and make it legible. I'm going to have 4 plus or minus the square root of negative 36 all over 2. Okay, but the square root of negative 36 is 6i. So I'm going to end up with a 2, like here, if I separate this, I'll have 4 over 2 plus or minus 6 over 2i. Both of those reduce, so I get 2 plus 3i and 2 minus 3i as my last two zeros. And that makes sense because I got one real and two imaginary, and my two imaginary are complex conjugates, which is exactly what they have to be. They come in pairs. Okay, find all real zeros. Nope, sorry, all zeros. So they won't necessarily be real. All of them is going to be 3. Given that, oh, lovely, that 6i is a 0. So I actually know 2 of them, because if 6i is a 0, I immediately know that negative 6i is a 0, and I'm just looking for my last one. So that's good news and bad news. The good news is I only have one to find. The bad news is I need to do synthetic division using imaginary numbers. It is messy in the first row and then always cleans up. So I'm going to go ahead and start with 1x cubed, negative 3x squared, 36x, and then 108, that's negative. And I'm going to put a 6i in the box, which is going to get yucky, but I can survive. So I drop my 1, and I'm going to get a 6i here. That's going to give me negative 3 plus 6i. Okay. Now I need to do what I always do and multiply this to get the box. So let's go over here and do some work. 6i times negative 3 plus 6i, I'm just distributing, is going to be negative 18i, and then here 36i squared. Well, 36i squared is going to be a negative 36. So I have negative 36 plus, oh, sorry, it's not going to be a plus. Looking back over there, it's a minus 18i. So when I go to combine them, these actually cancel because only the real parts can be added or subtracted. And so I end up with a negative 18i down here at the bottom. So I still have to take my side little box number times the bottom. And so when I multiply that, then I get negative 108i squared, but that I squared is a negative 1. And so it ends up turning this into a positive, so these cancel as they should, because I was told that it was a 0, so it has to have a 0 there. But the fact that they told me 6i was a 0 means negative 6i is another 0. So I have to go another round. I dropped, and in this round, all the imaginary numbers need to go away or something's wrong. So I drop a 1. This product becomes negative 6i. Now these two can combine and cancel, leaving me with just the negative 3. And then here I get 18i, which cancels and leaves me with a 0. I've gone from an x cubed to an x squared to a plain x. So I'm currently at x minus 3 equals 0. So finding my last 0 is actually pretty easy. It would simply be a 3. If they wanted the factors of this, I would have x minus 6i, x plus 6i, and x minus 3. Make sure you understand the difference between asking for zeros and factors, and all means all. So if they gave you 1, write it down. Okay, concepts. I love these questions. These are so fun to think through. How many real zeros could a 5th degree polynomial have? This is fundamental theorem of calculus. Ooh, more than one answer. Even better, smiley face. So think about it. You have 5. They're going to split into real and imaginary because they can't all be imaginary. That's a good true-false question. Could they all be imaginary? No. Why not? Because you have 5. And imaginaries come in pairs, and 5 can't accommodate pairs. So I could have 1 real with 4 imaginary. I can't have 2 real because that would force 3 imaginary, so that combo is not going to work. Could I have 3 real and 2 imaginary? Yes, because these have to come in pairs. Can I have 4 real zeros and 1 imaginary? No, because the imaginary have to come in pairs. Could I have 5 real and no imaginaries? Yes. So all of my imaginaries have to be 0, 2, 4. And so the options for what they're asking me for, it says how many real zeros could it have? The answers are that it could have 1 real zero, 3 real zeros, or 5. Okay, I'm finding a polynomial, so I'm going to start with f of x equals. These are my zeros. It's not saying anything. Oh, just leave it as factors. Okay, so if 0 is a factor, excuse me, if 0 is a 0, then x is a factor. Think your way through this whole negative 2/3. I would end up needing 3x plus 2. I need a factor to go with here, but look at that. That's repeated. So the factor that goes with the 0 of 2 is x minus 2. But the fact that it's got multiplicity of 2 or repeats twice means I put a 2 up here. Then I have a negative 3, so that would make x plus 3. And then I have, ooh, this is tricky. Then I have this. Ooh, this is really tricky. So remember what I need to do. I need to always take x minus my 0 value. So when I distribute that negative, it becomes x minus 1 minus 2i. But this is going to be the sneaky thing that everybody forgets. If you are told that 1 plus 2i is a 0, then 1 minus 2i is also a 0. And the factor that would go with that would be x minus that 0 value, which will turn into x minus 1 plus 2i. So this one's kind of the sneaky one at the end because it's implied. As soon as you're given one imaginary, you know a second imaginary. So did I do what it asks? Did I find a polynomial? Yes. Did I use these as my zeros? Yes. Did I leave it as factors? Yes. The grand finale. Okay. If negative 3 is a 0, then what is a factor? This feels too easy, but I'm just going with it. If negative 3 is a 0, then x plus 3 is a factor. Can a 6th degree polynomial have 3 real zeros? Counting multiplicities just means that you only have 3. So here is my 6. Can it split into 3 real, which would then force the other 3 to be imaginary? And the answer is no. And the reason it's no is that I can't have 3 imaginary. Why can't I have 3 imaginary? I can't have 3 imaginary zeros because they come in pairs. And 3 can't accommodate pairs. So I can't 3 imaginary zeros because they come in pairs. So I need an even number of them. And having 3 real forces 3 imaginary, and 3 imaginary can't be pairs. If 1 minus 3i is a 0, then what is another 0? So it's different than up here when it said, hey, if this is a 0, what is the factor? It's not asking me that. It's asking for another 0. And since they come in conjugate pairs, which, by the way, has come up approximately a bazillion jillion times, so know that, I would need the conjugate of 1 minus 3i, which is going to be 1 plus 3i. And the grand finale of reviewness, what is a minimum degree of a polynomial with a 0 at 2 minus 3i? Okay. So the number of zeros is going to equal the degree, but if I know this, then I know a second 0 has to occur at 2 plus 3i because for the jillionth and one time, they come in pairs. So since I know for sure I have 2 zeros, I have to have at least a second degree polynomial. So these concept questions at the end are the ones that turn into like true, false, or even just answering them like this. You have to just noodle your way through it and think about what concept is it referring to. So hopefully that helps you be an absolute expert on all things so you can ace this fun little celebration of knowledge. All right, peace out.